Hey everybody, I'm going to take you through how to solve a simple projectile motion problem. This one comes straight out of the book, number 21. We've got a ball that's thrown horizontally at 12 meters per second from the roof of a building, and it lands 21 meters from the base of the building. How high is the building? So as always, I'm going to go ahead and start off by when in doubt, draw it out. I'm going to draw a quick sketch of the situation. All right, we've got our ball being thrown horizontally, and in this sketch I'm going to include all of my information. So I know that's being thrown horizontally at that speed. So I know that the initial velocity in the x direction, in the horizontal direction, is 12.2 meters per second. From the roof of a building, it lands 21 meters from the base. All right, so here's the base of the building. It's going to land, not drawn to scale, 21 meters away. All right, so that gives me my horizontal displacement, or my horizontal range is equal to that. And then once that ball leaves that person's hand, it is going to start falling, and as it falls, it's going to accelerate. Okay, not a perfect parabola. I think I did mention not drawn to scale, all right, but it's going to follow roughly a parabolic path. And we are supposed to figure out how high is the building. In other words, from here down to here. We're supposed to figure out the vertical displacement. All right, what else do I know about this? I know the initial horizontal velocity is 12.2 meters per second. Since it's being thrown horizontally, I also know that the initial velocity in the y direction is 0 because it's being thrown with only a horizontal velocity. The other thing I know is since it's being thrown on the face of the earth, I know that the acceleration in the y direction is 9.8 meters per second squared down. Okay, so in class, I suggested that you make a T-chart, and let's make that T-chart big enough so that we can do all of our work for each axis in its respective space. And I'm going to start listing what I know in the x direction. So in the horizontal direction, I know that the initial velocity is 12.2 meters per second. I know that it goes through a horizontal displacement of 21 meters. I also know that in the horizontal direction, there is no acceleration. If there's no acceleration, that object must be traveling at a constant speed, at a constant velocity. If it's traveling at a constant velocity, then I know the only other variable that I can work with in the horizontal axis is the amount of time it takes for that to occur, which we don't know, we weren't given. Let me slide over here. In the vertical direction, what do we know? I know that the initial velocity in the y direction is 0 because it was thrown perfectly horizontally. I know that it's accelerating in the y direction at a rate of 9.8 meters per second squared down. What am I trying to find? I'm trying to find this. Now, if I take a look at my kinematic expressions, there's not much I can do with just 3 variables. So I've got to figure out some other approach here. This is where this comes in handy. Since this is a constant velocity, since objects can only move at a constant velocity horizontally in projectile motion, I know that this must be true for any projectile motion. Well, if that's the case, if I know the displacement and the velocity, I should be able to find out how much time it spent in the air because it was in the air until it hit the ground. So I'm going to solve for that, do a little algebra here, and I get that. All right, now it's time to plug and chug. I know that I had a displacement of 21 meters. And I know that I had a horizontal velocity of 12.2 meters per second. Meters cancels out. I've got 1 over seconds at the bottom, that'll flip. So that's my way of double checking that my unit's gonna be in seconds. That's units of time. That gives me a time of 1.72 seconds. All right, going by SIGs, because I believe that was a 21.0 if I remember right. So now I know that. That is not only true here, but it's also true here because it can only be in the air as long as it's in the air till it hits the ground. So now I know the time that the ball spent in the air is 1.72 seconds. Now I've got these four variables to work with. Well, if I take a look at my equation sheet, then I see that there's only one kinematic expression that fits all of those. And that is this one. Good old displacement equals initial velocity times time plus 1/2 acceleration times time squared. In this case, my initial velocity, and we are talking about all in the y direction, my initial velocity in the y direction is 0, so that drops out. That whole term does. So now I'm left with this, only because the initial velocity in that direction was 0. All right, and I can plug everything in, 1/2 times negative 9.8 meters per second squared times a time of 1.72 seconds quantity squared. And then when I run that through my calculator, plug it through, I should hopefully get 14.5 meters, and that's a negative 14.5 meters. What does that mean? Well, remember, positive negative just tells us direction. Well, since by calling negative down, by saying that the acceleration of gravity is in the downward direction, I'm saying that anything with a negative sign is downward. So what was the displacement? The displacement was 14.5 meters down from where it started. All right, final answer. Let me know if you have any questions.